Hi, interview team. I'm applying for this job. I need to implement a smart contract to support the NFT market, and I need to integrate Web3 wallet on the front end. Before we start, we can take a picture to design the NFT market. Okay, in this process, we have three roles. One is the seller who wants to sell his NFT, and one is a buyer. He can buy the NFT from the NFT market. When a seller sells an NFT on the market, he needs to provide the attribute about this NFT, like the picture, the description, and for the ERC21 need token ID. And he can set a price. He need to sell this NFT to earn money. And for the NFT, he provides this service from seller to buyer. So it wants to earn a market fee. When the seller uploads his NFT on the market, he needs to pay a market fee. And the NFT market also needs to hold this NFT. Because when a buyer looks through from the NFT market and choose one to buy, he needs to pay the price first, and the price will be transferred to the seller. After that, the NFT will be transferred from the market to the buyer. This is a brief description of this process. Now we can look at our smart contract. We can use OpenZeppelin's smart contract, ERC 721, and it has a constructor. We need to provide name of this NFT and symbol. So here the name is NFT Marketplace, the symbol is NFTM. And when we create this NFT Marketplace, remember that someone need to pay for the NFT market fee. So we need a payable message for the owner who creates this NFT. And at the end, he can receive this market fee. In my opinion, there are two paths in a smart contract. One is state by the stored variable, and one is the logic by the function. In a minimal ERC 721 smart contract from OpenZeppelin, we found two important functions. One is mint, which can create NFT. One is set token UI, which can provide the NFT attribute. So here are two important parameters. One is called token ID, one is called token UI. Look back at our smart contract. We also need a storage variable called the token ID. And we need owner who create this smart contract. When we want to list this token on the market, we need storage his information. This represents the token ID when mint this NFT. This represent the owner of this NFT. This represent who sell this, and this represent his price, and whether it's currently listed. So this is abstract for one NFT, and if we want list all of our NFTs, we need a map minting the information with NFT ID and its detailed information. So in our Dapp, we have three important functions. One is create token, one is get all NFT, and one is execute sale. We can look this from the true process. Now we enter this project. We should log in first. Click the Connect with Wallet button. And it will switch to the profile page. And now, if we want to sell an NFT, we need to upload it first. On our sell NFT page. So here is the metadata we need to provide. And we can this account named Z. We can set a price. And we need to choose field. Here in the front end, we upload this field to the Pinata and use this response data to assemble the token URI and upload this token URI to the Pinata. And after that, we can mint NFT now. So this will call the create token function. The token URI we have created, and we have set a price. Before we create a new NFT, we will get a new token ID by increment. After that, we use SafeMint function, mint this NFT to message sender. So it will mint on the 0 address and transfer to the message sender named Z. And Z will transfer this token to the marketplace, so the marketplace can hold this NFT. And emit token list successful event can help front end to now the NFT have created. Once we finish create this NFT, the page will automatically turn to marketplace, and we can find this NFT in our market. The name have 99, which we set before. So this is how we can create a token by the front end. And this function help us to list the NFT on the market. So now, if someone want to purchase an NFT in this marketplace, how can he does it? Here is another browser with another MetaMask account, and we can log in first. He is a buyer and he want to buy this 99 NFT, and he can click this button and buy the NFT. Sign the transaction by the MetaMask. So it will call this function, and here are 4 important things. The NFT marketplace need to transaction this NFT to the buyer, and we also can approve marketplace for the buyer, and maybe it can be resale. Now in the buyer profile, we can find that he has already hold this new NFT. Now we want to clear the fee in this process. One is a market fee when seller create an NFT. So this create function is payable. When we create a token, we need to pay at least 0.01 Ether for the market. After that, the buyer pays the price. In our execute sale function, it also payable. So this price will be transferred from the buyer to the seller, and the market fee will be transferred from the NFT market to the owner. Now let's consider it about the front end. When we deploy our smart contract on-chain, in this example, I developed it on the Sepolia testnet because it's free. And we will get a very important information called ABI, Application Binary Interface. So this ABI is a key the front end interact with the on-chain programmer. Remember our upload NFT page. Now we can use about 2 popular ways to achieve. One is use Ethers.js, and when we log in our wallet the MetaMask will inject the window.ethereum in the browser, and we can get the provider and sender. If we want to execute a function, we need three information. Remember that when a seller on this page wants to create an NFT, he must pay the market fee. Here is listing fee. And we need to get this listing price first. Use Ether.js. We need the contract address, the API, and the signer. So we can get a contract instance. And use this instance, we can call this function get list price. Now we can create token. We need to provide the metadata URL, which from the pinata response, we need to set the price, and this value is for the payable. So the payable in the smart contract also need a parameter from the front end. Now we know how can we use Ether.js to interact with the on-chain programmer. To actually work, we can improve our efficiency by some popular solution. Here, we can add the Rainbow Kit provider. So this login button is Rainbow Kit. And Rainbow Kit is a React library. Use Vigmi. So here is a example. Prepare to log in our programmer. Maybe user click this sell NFT, but it will turn to login automatically. How can we achieve this? So we can use Vigmi hook called user account, and we can get is connected from this hook. The Vigmi provide so many hook to use, and we can use read contract to just read, and it also need API contract address and function name. Looks same like our Ether.js do, and use read contract to read the contract, and we need to provide the args. And like this, use transaction confirmations. We can get a state if this transaction is confirmed by the chain. What can we do to improve our develop? Is this code organized well? Look at this project. It's a massive project. Use Chainlink, VRF, and automation. Patrick tells us follow this best practice to organize our code, and we can do some gas optimized and security check. Look, this require this long string It will cost a lot gas, and we can replace it by customer error. A for loop in our smart contract. We need to cautious this variable. If this is a storage variable, every time we view a storage variable will cost a lot. And here, why we need to approve this NFT after the transfer, so it can prevent the reentrancy attack. We should use AI to improve our efficiency. And looks like this contract. We can tell the ChatGPT, this is a marketplace contract. Can you write some basic test for it? This is a new function, and he used Parthead to write a test. So we need to learn how to use AI, and also we need to read the official document, and sometimes we need to search on Google. So use AI make life easier. Thanks for watching. This is all I want to tell you. And my name is Alex Hu. Looking forward to your review.